Alright guys, so make sure that you go back and watch 64. So if you haven't watched 64, this may not make a whole lot of sense. So this is just a continuation of what happened in 64. Now the only difference is that on this worksheet they don't actually tell you what u is supposed to be. Alright, so here's three rules right here, are good choices for substitution. If g of x appears to be raised to a power, if g of x appears to be in the denominator, and if g of x appears to be inside a function of a composition. So those are pretty good choices. Alright, so if you notice on this one right here, this quantity right here is being raised to the second power. So that would mean, if I'm using this choices right here, that u would be equal to x squared plus 1. Right, and if that's u, the derivative of that would be 2x dx. Alright, so if you look at it, now I'm going to substitute. Instead of x squared plus 1, I'm going to have the integral of u squared du. Alright, so one more time, what I did here is I replaced this with u. Right, so that's that number right there, or that letter. And I replaced 2x dx, I replaced that with du. Alright, so notice that I just substituted. So once you have done that, then the rest is relatively simple. You're going to integrate that, which is going to be u to the third power over 3 plus c. Alright, and just like on 64, after I've done that, I'm going to substitute back. So I'm going to substitute x squared plus 1 instead of u. So the answer is going to be x squared plus 1 cubed over 3 plus c. Alright, again, so if this substitution stuff does not make sense to you, go back and watch 64. Alright, on the next one, alright, notice that right here you have cosine of 5x. So this is basically your rule, I don't know if you want to call it a rule, but our choice number 3, you have a g of x appears to be inside a function. So this function is inside another function. Alright, so we're going to call that u. We're going to say that u is 5x. Alright, and du, that's going to be 5 dx. Alright, again, notice that if for some reason you do something wrong, it's okay to make a mistake. Just make sure you notice that on this one I have u is 5x. Alright, and du is 5 dx. So I have 5 dx. So that's going to be equal to cosine of u du. Right, where this right here is u, and this right here is du. So again, notice that I substituted this. Alright, so now the answer to this, the antiderivative of cosine is sine u plus c. Alright, finally I'm going to substitute back. So this is going to be equal to sine of 5x plus c. And that's it for that one. Pretty simple. Alright, let's go to number 3. Notice that on this one, I could rewrite this one as the integral of 2x minus 1 to the 1/2 power dx. Alright, so if I have that, notice that I have this quantity and it's being raised to a power. So this 2x minus 1 is going to be u. So u is 2x minus 1, and du, the derivative of this, is going to be equal to 2 dx. Alright, now if you look at it, I have 2x minus 1, so 2x minus 1 would be right here. But if you notice, I only have dx. Alright, so I have dx right here. I don't have 2 dx. So just like we did on 64, what we're going to do here is we're going to get rid of this 2 by dividing both sides by 2. Alright, so on this one, we're going to go ahead and substitute. So 2x minus 1 is now u, so we have u to the 1/2 power times du over 2. Right, that du over 2 came from here. See how dx is equal to du over 2? So I replaced that dx with du over 2. Alright, just to simplify that a little bit further, I'm going to write this as 1/2 integral of u to the 1/2 du. Alright, so all I've done right now is I got the constant, this constant right here, I got it out of the integral. Alright, so that's what I've done so far. Now I'm going to integrate. So this is going to be, well, the 1/2 stays there, and this is going to be u to the 3/2 over 3/2 plus c. Okay, so this is going to be 1/2 times 2/3 u to the 3/2. And this might be a little bit weird, but if I multiply 1/2 times a constant, that's still going to be a constant number. Alright, so this is still going to be c. It's not going to be half of c. It's just going to be c. So again, it's just a constant. So if you split a constant in half, you still have just another number. Alright, just another constant. So therefore, if I cancel that 2 right here, I'm going to have 1/3 u to the 3/2 plus c. And then finally, I'm going to substitute back. So instead of u, I'm going to plug in 2x minus 1. So the answer is 1/3 2x minus 1 to the 3/2 plus c. And that is my answer. Alright, let's go to example number 4 now. Alright, on this one it might be a little bit hard to tell what to make u. Alright, so in order to figure out what a good choice for substitution is, at first I looked at the 3x and I thought, well, maybe it's just 3x. But if you notice, right here you have a sine squared 3x. Now that sine squared 3x, remember that's the same thing as saying sine of 3x squared. Alright, so again, this is the same thing as having this times the cosine of 3x dx. Alright, so notice that now I have a quantity square right here. So I have a quantity square, so what I'm going to do is I'm going to say that I'm going to substitute. The good choice for substitution here is sine of 3x. So we have u is equal to sine of 3x. Okay, the derivative of that. Remember, when I take the derivative of this is going to be a chain rule where the outside function is going to be sine and the inside function is going to be 3x. So the derivative of this is going to be equal to 3 cosine of 3x dx. Alright, so notice that I almost have everything I need here. I have sine of 3x. Alright, so let me write this over here. But notice the sine of 3x, well, that's this quantity over here. So that would be u. And then the derivative is cosine 3x dx. But notice that on this one I have a 3. Alright, so to get rid of that 3, I have to divide it, just like the last problem. Divide both sides by 3. Alright, so notice that now I have sine of 3x, which is that right there, that quantity. And the derivative of that is going to be cosine 3x dx. Cosine 3x dx. Okay? So, let's see. This is going to be u squared times du over 3. So that's what I'm going to have. So now all I have to do, well, I'm going to go ahead and get this 1/3. Well, I'm going to write it like this. You don't have to necessarily get it out if that really bothers you. You can just leave it in there. And now I'm going to integrate this. Alright, so notice that this is going to be equal to u to the third divided by 3, but when I multiply that 3 on the bottom of this times this 1/3, that's going to be 1/9. Alright, so again, this would be 1/3 times u3 over 3 plus c, which is equal to u to the third over 9 plus c. Alright, which finally will become, I'm going to substitute the sine of 3x back. So I have sine cubed of 3x over 9 plus c. And always remember the sine cubed 3x is the same thing as having sine 3x cubed. Alright, so that's it for that one. Now on the next one. Alright, on the next one, example number 5, let's see if you look at the front of this paper. Alright, if you look at the front of this paper, it says that one of the good choices for substitution is when it appears in the denominator. Alright, so let's take a look at the denominator. And notice that the denominator is being raised to a power, so if I say that u is x to the 6th power plus 1, then du would be x to the 5th power dx. Oh wait, that would be 6x to the 5th power dx. Alright, and if that's the case, then notice that I have almost everything I need. Alright, I have, let me write it, see if this makes any sense. Notice that this right here, okay, is this. Alright, so that right there, notice that I have an extra 6. I don't have a 6 anywhere on here. So what I'm going to do, just like the last two, divide this by 6, divide this by 6. So now I have exactly what I need. Alright, so this is going to be 1 over u to the third. Remember that this is u, so this is u to the third, times x to the 5th dx. Now that's going to be equal to du over 6. So this is going to be du over 6. And now that's equal to, let's see, 1 over 6 u to the negative 3 du. Okay, so again, notice that I took out this constant 1/6 and I just moved that out in front of everything. Right, and again, you can move that 1/6 completely out of the integral if you want. That's really up to you. Alright, so now I'm going to integrate this. So we have 1 over 6, that stays there. I'm going to add 1 to this, divide by negative 2. So we have u to the negative 2 over negative 2 plus c. Okay? Now this is going to be equal to 1, wait, yes, 1, well, alright, u to the negative 2 over negative 12 plus c, which really, this is going to be equal to 1 over negative 12u squared plus c. So the answer is going to be 1 over negative 12 x to the 6 plus 1 square plus c. And I think I forgot a negative. Oh, wait, no, the negative is down there. Okay. So again, I have a negative. It doesn't look like it maybe, but I have a negative here. Okay. So that is the answer. Right, so if this is starting to get too difficult, just make sure, just to practice, the more you practice, the easier this gets. Alright, so finally, example number 6. Alright, we're going to have to look at the denominator. Well, this is in the denominator, number 1, but also is being raised to a power. So you have two things that kind of tell you that that 2x minus 1 is u. Alright, so u is equal to 2x minus 1. du is going to be equal to 2 dx. Alright, so this one's going to be the slightly more complicated one because I have the dx. Well, first of all, I don't have a 2. Outside of this radical, I don't have a 2. Alright, so I'm going to have to divide by 2. Alright, so notice that now I have u. This is u right here. U to the 1/2. I have dx, but I don't have x. Alright, so I'm going to write here I need an x. And if you look at the lesson 64, I think one like this, or maybe 2. So make sure to look at lesson 64 if you don't understand this next one. Alright, I need an x. So to do that, what I have to use is I have to use this original substitution, and I have to solve for x. Okay, so I'm going to have to solve for x. So start off by adding 1 to both sides, so you have u plus 1 is equal to 2x. Divide both sides by 2. So notice that now x, and I'll rewrite it here, x is equal to u plus 1 over 2. Alright, so we're going to need all of that now. So please notice what I'm going to do here. I'm going to have the integral of, notice that x, this x right here, is now u plus 1. And I guess I'm going to have to write it like this, hopefully you understand that. U plus 1 over 2 over u to the 1/2 power. And then finally dx, du and dx, this is going to be du over 2. Alright, so if you write like this, it looks really complicated, but what we can do to simplify this is, if I want to bring this to the top, I'm going to make this, that looks really blurry, but anyway, I'm going to make this negative. So this would be the same thing as having u plus 1 over 2 times u to the negative 1/2 du. And instead of writing du over 2, well, you know what, I better not skip any steps. Du over 2. Okay, so now what I'm going to do here is I'm going to distribute this guy to those two numbers. Alright, I'm going to multiply that 2 and that 2 together. So this is going to be equal to 1/4. Remember that 1/4 came from multiplying those two together, and I'm going to get that out of the integral. So I have 1/4 u to the negative 1/2 times u. Remember, you add the exponents. This has an exponent of 1. So this would be u to the 1/2 plus u to the negative 1/2 times 1. That's just u to the negative 1/2 du. Alright, notice that du came from here. That 2 that was used to be here, I multiply those two together, and that became the 1/4 that I have right here. Right, so if you follow all that, if you were able to follow all that, the last part should be simple. Alright, so now I have, just integrate this now. So we have 1/4. And I just leave the Gora details up to you, but add 1 to this, that'll be 3/2. If you divide by 3/2, that's 2/3. So I have 2/3 u to the 3/2 plus, if I add 1 to this, that would be 1/2. If I divide by 1/2, that's the same thing as multiplying times 2. 2u to the positive 1/2. Okay, plus c. Well, what I tell you, if you multiply 1/4 times the constant, that's still going to be another constant. Okay, so you don't have to write 1/4 c. If you did, it would be fine, but you don't have to do that. So again, I'm going to distribute this 1/4 across this 2. And when I do, let's see, that would give me a 1 over 6 u to the 3/2, or u to the 3/2 over 6, same thing, plus that 4 and that 2, that would give me a 1/2, or u to the 1/2 over 2 plus c. Again, you can write 1/4 times c, which is a constant, but 1/4 times a constant is still just a constant. Okay, so finally, what I'm going to do here is I'm just going to substitute back. So instead of u, I'm going to write the 2x minus 1. So we have 2x minus 1 to the power of 3/2 over 6 plus 2x minus 1 power 1/2 over 2 plus c, and that is your answer. Alright, please make sure you don't get lost this early on in this lesson. Alright, we don't have a whole lot left to go. So if you got any questions, make sure and ask me. Work on your homework. Alright, goodbye.